Welcome to session 3 of eXseniarch React Native tutorial series. In this session, we are going to learn some basics about React Native architecture, how it interacts with host operating system, what are core components, what are package manager and community components, and why Yarn is a great handy package manager for React Native developers. To understand how React Native app works, that's great to be familiar with React Native's architecture. This needs time and full of technical details, needing a lot of theory to know that as a developer, you could ignore all these deep down details and go through just knowing some briefs like React Native's new architecture promises consistency, faster startup, fewer data serialization, better performance and type safety, and the most important of all, C++ core, which is shared on all platforms. All these will be understood as we progress developing with React Native. In React Native architecture, what we need to know is a little bit on how a React Native app interacts with its host operating system, and to ease this model, let's assume it as simple as possible by introducing 5 actors. Actor number 1. React Native's code is actually a kind of JSX because of being a composition of JavaScript codes and HTML-like tags. She knows how to talk to user and send user requests to the background mechanism, and how to show the responses like showing and scrolling a menu and its content, pushing a button, typing into an input box, and all the stuff alike. Actor number 2, Metro Bundler. He bundles your code, filtering only those libraries, assets, and UI items used in your code, consisting core components like buttons, input boxes, checkboxes, and community components like camera and sound handlers and image gallery. Then he bundles these whole in one place as a single file and hooks all their activities to certain functionalities of actor number 3 called NodeJS, a browser-independent runtime environment which is native to your host. There exists a kind of client-server relationship between your React Native code and Node.js, in which Node.js plays the host. Now Metro acts as a compiler, bundling all these together with the native code of your host machine in one place as your application's executable. And finally, actor number 4, host operating system, like Android, iOS, or Windows. He uses his API to respond all the requests of the bundle, as now he knows how to talk with whatever there is. All that you see in this diagram is simplification of what really happens for React Native app to work as an image for simple development. So remember, there's a lot to learn in case you wish to work and develop for each of these modules other than React Native app. This way of thinking makes it easier for a React Native application developer who's gonna write code once and run everywhere, while React Native team are busy developing robust intermediate layers for different host operating systems, and you will not need to care about it. Besides, although React Native team are doing what they can, there is a lot of unhandled capabilities of any host operating system inside React Native's default components, the same core components. So a huge community team of thousands of developers around the world are handling these capabilities as third-party components, and you can simply just use them with help of actor number 5 called Package Manager. Package managers, like Node.js's default npm CLI, can inject extra components and codes from npm registry into your React Native app. Community developers made these libraries a way capable to interpret app users' requests into API commands of host operating system. Components which are capable of opening photo gallery, take a crop photo, play sound, and etc. Developers of such components have to deal with API commands that vary from one operating system to another. Other than npm CLI, there exists another package manager called Yarn, which you will find a lot handier. For example, it's capable of concurrent package fetching and installation instead of npm's serial fetching and installation system. Now let's get back to work and see how to set up and use Yarn, this handy and sharp package manager. First, open a PowerShell window and type in npm install -- global yarn. Well, when it's done, to check if it is installed correctly, you have to simply type in yarn -- version and press enter. You may face this error over here, saying running scripts is disabled on the system. To remove it, just type in set execution policy and removed signed. Type in Y and accept changes. And now run the yarn check command again, and we will have our yarn installation checked if it's done correctly. Thank you for watching. Join our channels to become an expert senior architect.